Okay, guys, here we go. Third video of 12.2. Now you may use your calculator. And you know, when you're using calculator, Desmos calculator, oh, well, it doesn't have to be the Desmos calculator, whatever calculator you're using, because just any scientific calculator is going to have this NCR function built in somewhere, as well as the NPR function from last class. But the Desmos calculator is super easy. Just type in lowercase n, capital C, lowercase r, parentheses, and then the bigger number followed by the smaller number. So very similar to how we did NPR function last time, except you just change it to C. C for combination, just like P was for permutation. Yeah. Okay, so yeah, it's actually super easy in terms of calculation now because we're just gonna punch it in there. And really, I think the bigger challenge is gonna be to know when should I use the combination versus permutation. So let's think of a few scenarios together. And we're just answering permutation or combination. As always, give it a crack before you watch the answers with me. And then let's do this. 12. 3 offices are chosen for government. President, vice president, treasurer. How many outcomes are possible? Is that a permutation situation or a combination situation? And the answer is permutation. Permutation. All right, perms for short. Perms. Why? Because I have distinct position, right? So anytime you have president, vice president, treasurer, you got places, first, second, third place, first, second, third, fourth, fifth place, or anytime you have position, or order like that mattering, then that's going to be a permutation. Okay, number 13, 3 equal winners chosen to win the lottery. How many outcomes are possible? That would be a combination. Let's say combs. Combination because they're equal winners, right? So doesn't matter which order they come in, just that there's 3 of them. They're all basically equivalent. So the order does not matter here, hence combination. 14, 3-person committee is chosen for a government. How many ways can they be chosen? This one again is combination because it's just a 3-person committee. It doesn't say that they're distinct members or distinct positions within the committee, just that there's 3 people in there. And I chose this for a reason because this question sounds kind of similar to question 12, right? I mean, you could even say they're both committees. But in question 12, if you now decide there's going to be 3 different distinct positions, president, vice president, treasurer, that makes it into a permutation. Versus 14, where we don't have those distinct positions, so it's just a combination. Number 15, 5 stars selected from a basketball team of 12 players to play unique positions. Okay, this is where it says unique positions. How many choices are possible? Here we're going to say permutation. Yeah, because you have different roles here. You have like a center, you have a guard, and so, etc. So because of that, distinct positions, it pushes it to a permutation. Perms. Okay, number 16. So you have 4 letters, A, B, C, D. How many 2-letter permutations are possible? Okay, note guys, these questions now, they could go either way. They could be permutations or combinations. This one's of course super obvious because it says permutation, right? So how would you do this? Very easy. This would be NPR question, right? And how many things are you choosing from? You got 4 letters. So bigger number is 4, smaller number is 2 because you have 2-letter permutation, sorry. And once you got that much, you can just plug it into your calculator. Here I have it prepared. NPR 42. Yeah. I mean, this is a pretty easy one. I could actually do it by hand, but I'm gonna just cheat because I don't know, because I can. So NPR 42, result is 12. Let's switch colors here for the next one. Okay, 4 letters, A, B, C, D. How many 2-letter combinations are possible? That means how many ways can just pick 2 letters? I don't care what order they come in. That'd be NCR, bigger number, followed by smaller number. Yeah. It's gonna end up being 6, but let's just demonstrate how to plug that in. So I'm looking this time for NCR. If you're using a handheld calculator like me or iPad or iPhone, then you're gonna actually you can't use an iPhone on the exam, so you should be using computer or just a scientific calculator. Okay, so if you're plugging this in, big number followed by small number, parentheses, right? And you get 6. So 6, sweet. 18, how many 3-person groups can be formed from our class of 30 students? So notice just 3-person groups. Doesn't specify positions or ranks or anything. So that means it's going to be a combination, NCR 30, comma 3. Right? Guys, as always, make sure you're trying these on your own before you confirm with my answers. 30, comma 3. Oh, you know what you can also do, guys, is you can kind of do something like we did with our finance formulas. So I'm gonna do this. Check this out. So I'm gonna write n comma r for both NPR n comma r. I have both formulas ready to go. And then what I'm going to do is just have my n ready and my r ready. And I'll just fill in the numbers. So let's redo the previous ones, like 4, 2. You see my 2 answers, 12 and 6? Pop out, right on. Sweet. what number I just doing? It was 30 and 3, I think. 30 and 3. And I wanted the combination one, yeah? 4060. Well, this is kind of nice, too, because I can compare the two. Permutation versus combination. So anyways, I got 4060. Okay, switch to black. Number 19. A family has 12 children. How many ways can they have 4 boys and 8 girls? Okay, this one is an interesting question to me because, when you first read it, there's a couple things that make it interesting. This one can be confusing to determine whether it's a permutation or combination. So the answer is, it is a combination. And the reason it's a combination is because I'm just concerned with... how do I explain the reason for it being a combination? I'm not distinguishing between the individuals. I'm just taking all the different boys to be boys, either boys or they're not boys. The girls are either girls or not girls. No, I'm not saying this correctly. What I mean is, like, okay, you have 12 children, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so let's just focus on choosing the positions for boys. So position for boys, I have 12 options, and from these 12 options, I'm just picking 4 of them. So here's one possibility. First child, second, third, fourth child, fifth, sixth, seventh child. Those are the boys. I'm just picking amongst the 12 possibilities, 4 of them. So from 12, I'm choosing 4. Now, equivalently, so this is what? From the biggest number at 12, I'm choosing 4. Or you could also do... Oh, I'm sorry. My C's are looking like parentheses. That's getting confusing. Let me write that a little nicer. 12, 4. Or alternatively, you could choose from the 12, the 8 girls. Once you decide the 8 girls, then once you find the 8 girls, then the 4 boys are just gonna fill in the blanks, right? Or if you just decide the 4 boys first, then the girl spots are just gonna fill in the blanks. So either way that you go about it, you get the same result. And let's confirm that with a calculator. Watch. So if I have 12 children to choose from, right? And I do 4. I'm focused here on the combinations, yeah? Combinations, 495. Now if I choose the girls instead, still get 495. Same thing. Yeah. Curious. Kind of matches what we finished the last video with, where we had 10 choose 8 and 10 choose 2. Something to think about again. All right, let's go back. 495 is the answer. Okay, word of caution here, guys. Important word of caution. As I'm telling you this, I'm telling you that I can choose 12, choose 4, or 12, choose 8. But make sure you do only one or the other. You don't do both. So if I do both, I'm going to end up double counting. Right? I can choose to do 12, choose 4, or I can choose to do 12, choose 8. 495 is the answer. But you just do one or the other, not both. All right, I'm going to cut the video off here, and then in the next video, we'll finish up the remaining questions.